Hello again, this is Mr. Wakefield, and we're continuing on with Chapter 5, 5.2 today, and this is a big section. This is one that's got a lot of stuff going on, and we really need to talk about a few things here first before we jump into it to be careful that we don't go in the wrong direction with these problems. Let me read this important opening paragraph here. It says, if you're trying to solve a system of linear equations, just like we did in the last section, 5.1. What did we do in that section? We did these problems right here. Again, as it mentions, it's two variables, two equations, and they're linear, okay? And the ones today will be as well. It says that when you have one of those, that's different. But if it's not one of those two equation, two variable systems like we saw in the last section, all right, the way we do the problem in any other case when you're solving a linear system where all the equations are linear, no x squareds or y squareds, just x's and y's and things like that. In order to make sure you're getting the correct answer, we need to write the system as a matrix. I'll show you how to do that. And then you put this matrix into the following form called Echelon Form. Now, I want to back up for just a moment. Do I have to do it that way? Well, there are other methods, okay? This is the best one, though, I think, and it's not the same one as the one they use in the textbook. I'll get into that in a minute, all right? So you essentially could use the one that's in the textbook. It's called Gauss-Jordan Method. And it's not a terrible method, all right? I just think this one's easier for a couple of reasons, okay? Again, I'll mention what they are in just a moment. But the other thing I really want to encourage you about first, though, is don't make up your own stuff, all right? And I say that because it's really easy to look at these problems and kind of relate them to what we did in the last section and kind of do similar things there. You're not supposed to do that. Although there will be some similar things that we do compared to the last section when we had the two equations and two variables. But not everything's the same, and nor is it meant to be, okay? These problems are much more complicated than those problems, even if they don't look like it, okay? They are. There's a lot of different directions these problems could go in, and so you need to have a structured method that you use each time in order to be sure that you're going in the right direction each time. So a lot of students will make the mistake of thinking, oh, what I'm doing right now is, it looks logical. It looks like it makes sense, and so I must be getting the right answer. And in particular, sometimes students will even get an answer. They'll get a solution, and they'll even plug it back in to make sure that it makes all the equations true, which is what it's supposed to do when you solve a system, as we talked about in the last section. When you solve a system, the answer has to make all the equations true. So they might actually plug it in and find out, hey, that makes all the solution I've found makes all the equations true, so it must be okay. But that doesn't mean, though, that that's the only solution. Yeah, it may be a solution that you just found, and that's great, but when you solve anything, all right, including when you solve a system, you're supposed to find all of the solutions, not just one. Now, a lot of times there will end up being only one solution, and same thing as in the last section, but also, just like in the last section, a lot of times you'll get an infinite number of solutions, okay? And so just because you get one does not mean that that's the only one, all right, if you're being careless about how you're solving it, all right? But if you use this method I'm about to show you, okay, you will definitely get the right answer each time, all right? So please do not divert from that, even if it seems like it makes sense what you're doing, because, like I said, this thing is a lot more complicated than it looks, and so it's kind of deceptive. It kind of makes you think that, oh, I can just do this simple little thing that looks like it makes sense, and I'll be just fine. But not here, okay? Not in these types of problems, because, like I said, they're much more complicated than they look, and we need to follow a certain method. All right, now the textbook's method, as I was just mentioning, called the Gauss-Jordan method, it's okay, all right? It's okay to do that, but there's a couple problems with that, which makes me prefer the method that I have right here on the worksheet instead. And let me tell you what those things are. First of all, you'll see here in the textbook, it says in the final step of the Gauss-Jordan method, it says continue in this manner as far as possible. Okay, now to me, that's a pretty vague statement. All right, and we want exact directions here. We want to know exactly what to do, right? All right, we don't want any vague comments like that where we're kind of left out in the cold there. The second thing, and this is something that I think you'll appreciate, a lot of times, not all the time, but a lot of times when you do the Gauss-Jordan method like they did in this problem right here, look at all the fractions that end up showing up here. Now, I'm not saying that the method I'm going to show you doesn't give you any fractions. It does. But it won't give you this many of them. Okay, so what I show you here will not give you this many. And so it's always nice to avoid fractions as much as possible because they can be kind of tedious, you know, especially when you're adding and subtracting fractions and you got to get a common denominator and all that kind of stuff. All right. And we're going to be doing a lot of adding and subtracting. So you do not want to be dealing with a lot of finding the common denominator and all that kind of stuff if you can avoid it, right? So because of all that, I am now going to introduce to you this method here. It is not in the textbook, but it is right here on the worksheet, and that's where you can find it. It's called the echelon form of the matrix. All right, there's two rules to it. You need your matrix to be in this form right here with these two rules satisfied. I will talk about these rules here as we go along. I won't get into it yet because it's not going to make any sense to you yet until we actually see a problem and see it all come together. What I do need to tell you right now, though, is these three things right here, as we do each step of these problems, you guys, we're only allowed to do one of these three things on any step. Okay, as you continue to manipulate this matrix until it ultimately is in this form up here, the echelon form, okay, you're only allowed to do one of these three things. So you keep on doing one of these three things on each step until you get to a point to where these two things are satisfied. And again, I'll talk about these two things, all right, as we go along. It won't make any sense to talk about it yet, all right? After we get it into this form, then I'll talk about what we're going to do after that as well. So there's a lot of stuff going on here, all right? Don't worry, we're going to look at a lot of examples, all right? Let's go ahead and take a look at one example here first where we're going to actually write it out. If you have a sheet of extra sheet of paper in front of you right now, please use that, or you can use the back side if you printed this out. I'm going to write down a problem right here. And so go ahead and write it down either on a separate sheet, or if you, like I said, if you've got a blank backside to the sheet there, you can write it there. Either way, though, when we turn in our worksheet packet, just include that, okay? Include this problem here. This is part of our notes, all right? I apologize for not putting this in the packet already. But I'd like to, before we get into the other problems, I'd like to do this one here first. It'll make it easier for us to kind of get off to a good start here. So I'm going to write down this problem. You can see that once again, this is not a two-variable, two-equation system. All right. And so, like I said, that's different when it's not a two-variable, two-equation system. We are not going to do what we did in 5.1. This is in a whole different category. We're going to do the thing where we first of all what? We first of all make it into a matrix, and then we try to put it into echelon form, and then we'll go from there. So how do I make one of these matrix things that I've been talking about? Here's what you do. You first of all, make sure that all your x's are lined up. All your y's are lined up, all your z's are lined up, your equal signs are lined up, and your constant terms that don't have any variables in it are lined up. And so make sure that all your variable terms are on the left side, in other words, and make sure all your constant terms are on the other side so that it will line up nicely. Okay. And so if you need to add or subtract those terms over from one side to the other, do that. Usually it'll already be set up for you nicely like this, and so you won't need to, but just in case. So here's how you make the matrix. Basically, the matrix is the same thing as what you see written there. The difference is that you don't put the variables in there. Okay, it makes it a little bit easier. So for example, see how I'm just writing down the coefficients there? And same thing here, 3, 8, 4. I'm just bringing them down, okay? 5, 4, 1. Let me bring those down, 5, 4, 1. All right, and then instead of the equal signs, I'm going to put a bar here. So the bar means that's where the equal sign goes, okay? And then over here we got what? We got the constant terms over there. And then I'm just going to put these big brackets around it. It just kind of holds the whole thing together. All right, so what we need to do, as I told you a few minutes ago, when we get it into matrix form, we need to do one of these three things on each step, one of these three things, until it's in echelon form. Okay, so we need to do one of these three things, but how do you know which one to do? How do you know which one to do on the first step? How do you know which one to do on the second step? And so on. Okay, well, that's where this other sheet that I got right here, and again, this is not on the in the packet, but I'll be glad to email it to you. If you'd like me to provide that, you can take a picture of it right now, or if that's not, if it's your camera doesn't make that possible for you right now, I'd be glad to email it to you. And if a bunch of people want me to email, I'll just send out a mass announcement. That's not a problem at all, and I'll attach it. All right, but this is what we call the best strategy to get that matrix into what? Into echelon form. That's what we need to do. Okay, so this will help us realize, okay, what do I do first? What do I do second? And so on. It says right here, make sure there's a non-zero number in the top left-hand corner of the matrix. Okay, there is one already, isn't there? Okay, if there wasn't, then we could interchange the rows. Okay, you can interchange any two rows you want. That's one of the things that you could do on any step. All right, okay, but since I have the non-zero number already up in the top left-hand corner, I'm good with that. So what's the next step? The next step says use that first row to combine with each row below it. In other words, I'm going to combine the first row with the second row if necessary, and I'm going to then combine the first row with the third row, okay, in order to do what? In order to make all of the numbers below that top left number equal to 0. So in other words, you want to take the 6 and the 3 and you want to convert them to zeros. Okay? How do we do that though? What do they mean by converting that to zeros? How does it go? Well, you have to do, again, as with any step, you have to do one of these three things right here. All right? What we're usually going to do, more often than not anyway, is this third thing. All right? And this is something that we did in the last section, all right, where we let me just give you a heads up on that. When we did the elimination method, all right, sometimes we multiplied one row and then we added the equations together. And for the purpose of what? For the purpose of canceling out at least one of the variables. In this case, it canceled them both out, but usually it'll just cancel out one of them. Okay, this is no exception down here. It canceled out one of them. But speaking of this problem down here, sometimes you also multiply by both equations. So sometimes you multiply by one, sometimes you multiply by both, but what's important is that you cancel out one of the variables at least, okay? That's the same exact strategy that they are referring to here in the third of the three options that you have. It says add a multiple of one row to a multiple of another. In other words, they're saying multiply either one or both rows by something so that they'll be opposite coefficients like they were in the last section, so that when you add them together, a variable will cancel out. All right. You only need one variable to cancel out normally on each step. It's just that sometimes, occasionally, more than one variable will cancel out. All right, as we saw in section 5.1. All right, sometimes more than one will cancel out. Don't panic if that happens. It sometimes happens, but usually just one will cancel out. We're going to do exactly the same thing here, but the way in which we write it out is different, though. Okay. not just because the variables are missing on the matrix, but there's other reasons as well why it's going to be different. So listen closely here. But remember, I want to change the 6 to a 0, right? Okay, so what that means is that I want to do this. I want to add these two equations together so that the x's will cancel out. All right, because when you get 0, when you cancel out the x's, that's the same thing as 0x, you guys. That's the same thing as 0x. And so that would then make this a 0. And I'll explain why it does exactly in a moment. But when we want to make a 0 on a matrix, basically what that means is that we want to cancel out the variable where that 0 is located. So since this is in the x column right here, that 6 is in the x column, that means I want to cancel out the x's right here. But because the directions told me to combine the first and the second row to make that second number a 0, and it told me to combine the first row and the third row to make the third number, which is the 3, equal to 0, then that means they're telling us to add the first and second column here, or sorry, the first and second row together here in order to make that 6 into a 0. And then they're telling us to add the first and the third column together, first and third row together, pardon me, in order to cancel out the x's there and make this a 0. And I'll tell you how to write that out, don't worry. But in the same theme of what we did in the last section, how did we get the x's to cancel when we have x and 6x? What we did was we multiplied the first row by -6, didn't we? Because then that would make this -6x and +6x, and then it would cancel, wouldn't it, when we added the equations together. So with that in mind, we are going to do what? We're going to do -6 times the first equation, E1 first equation. And then after that, we're going to add that result to the second equation. I'm not going to multiply anything by the second equation this time, because if I do the -6, it'll already be opposite signs. All right, 6 and -6, that's what we want. Okay. Now to save time here, all right, do not actually write down an entire brand new equation or row of numbers here. In a whole separate step. You can write it right here on this step. But what do we do when we multiply this by -6? Just like we did in the last section, just distribute it to each term. Just like we did before in these problems. Okay, just distribute each term, keep the equal sign in the same place. What do we get? Well, again, you could just write this off to the side. I'm going to use a red pen so you can see the difference here. The 1 becomes a -6, doesn't it? I'm not subtracting 6 right here. I know it looks like that. The 1 is changing temporarily to -6. Temporarily. All right, I'll get into that here in a second. But the first row is ultimately going to stay the same, but just temporarily it's going to change from 1 to -6 because we multiplied 1 times -6. 3 times -6 is -18. 5 times -6 is -30. Okay, and then 26 times -6 is -152. Okay, and then what we're going to do is we are then going to, just like we did in the last section, after you multiply, you then add the equations together. All right. And what result do you get? Well, here you're going to get -6 plus 6 is 0. I'll write that down in a minute. Okay, -18 plus 8 is -10. And then these two added together are -26. And then these two added together will be -100. And you know what? I stand corrected there. That is actually -156. I actually got ahead of myself there because the answer is going to be -152. Okay, so that's -156. Added together, it's going to be -152. The question, though, is where do you put that answer, though? Here's where it's different than the last section in a big way. Okay, look at what it says here. It says after you add one row to another, you then put this result where? Well, it replaces one of the two rows. Okay, your choice, but there's going to be an obvious choice here. But it ultimately is your choice. One of the two rows you used in the step. what two rows did we use in this step? We used the first and this, in other words, the two equations that I added together, those are the two rows we used in the step. All right, that's the first and second equation. So do not put your result in the third line here. Okay, the answer that you get has to either go in the first row or the second row. We don't want it in the first row because we want that first row to have that non-zero number on the top left-hand corner. All right, remember that was the first thing that we made sure was true. So we want that result to go in the second row. Okay, so negative 6 plus 6 is going to be 0. Negative 18 plus 8 is negative 10. Negative 30 plus 4 is negative 26. Bring down that bar right there. And then negative 156 plus 4 is negative 152. Okay. And so now, here's the thing, you guys. When you do each one of these three things that I talked about, any one of these three things right here, in particular, actually, let's focus on number 3 here because that's what we just did. All right, it's only going to replace that one row. That result will then replace the one row that you chose. And again, I chose the second row like we just talked about. We don't want to ruin the first row with the number in the top left-hand corner. So I replace the second row with this result. The other two rows will always stay the same when you do that. Okay, when you do this third step, it's just going to replace one row. The other two rows will stay the same. Okay, and so let me just bring down these old rows here as they originally were. Like I said, the red numbers were just temporary numbers. All right, only one row is supposed to change when you do that thing where you add the two rows together. Only one row is supposed to change. All right, and so we did that. Okay, remember what we said that we have to do next, though. It says that you also need to have a 0 in all the numbers that are below that number in the top left-hand corner. So since I now need to make the 3 into a 0, okay, I need to what? I need to, as I said, I want to combine the what? I want to combine the first row with whatever row I need to change. So since I need to get rid of that 3 and make it a 0, I now need to take the first row and combine it with the third row. Okay, so how do I go about that? As you can see here, and you can kind of see it up here as well, I need to multiply this one now by what? Wouldn't negative 3 work this time, you guys? If I multiply this one by negative 3, I'm going to get negative 3x and positive 3x. That will make the x's cancel. And then we would then put that result in that third row, because when it cancels, you're going to have a 0 in that spot where it cancels, just like we did in the second second row here when we did that first step. And so that 0 would then go here. I'll get into that. Don't worry. We'll do it carefully and slowly here. But multiply my negative 3, what's that going to do to the first row temporarily here? 1 times negative 3 is going to be negative 3. Negative 3 times 3, again, I'm distributing here to each term, is negative 9. Negative 3 times 5 is negative 15. And finally, negative 3 times 26 is negative 78. And so now, since I want to change the 3 to a 0, it would make sense for me to add the first and the third row together, okay, and then put that result in the third row, okay. You might be wondering, could I do the second and the third row and then just put the result in the third row instead of doing the first row and the third row? No, you can't do this. You have to do the first and the third, not the second and the third. The reason why is because there's a 0 here, and you can't cancel. You can't get something to cancel if one of the two variables, in this case, these are both x variables, they're in the x column. If you're trying to cancel an x, both of the numbers can't be 0. Neither one of them can be 0, otherwise it won't cancel. Okay? Both of them have to be non-zero in order for them to be able to, multiply by something and then add it together. And so that's why I have to do the first and the third. Okay? So we do first and second. We already did that, and now we do first and third. Okay, so what I'm doing here is I'm just going to communicate this here in writing. I did -3 times the first row, and we're going to add that to the third row. And what do we get? Again, just the third row is going to change. In fact, let me write that down here. We wanted that result to go into the second row here, so I'm going to say that it becomes the second row right there. This one's going to become the third row right there. Okay, so that means that the first two rows are going to stay the same. I'm just going to write them down now. Again, when you do this thing where you add a couple of rows together, the other two rows always stay the same other than the one row where you're going to put the answer. And since I want that 0 to go down here, it's the third row that's going to change. Okay. Okay, so what did we get when we add the first and third row together? We get -3 plus 3 is 0. Okay, again, the result's going to go in the third row. -9 plus 4 is -5. -15 plus 1 is -14. Okay, and then finally, -78 plus 0 is going to be -78. Right? And so we did it. We did exactly what they asked us to do. Okay, use that first row to make all the numbers below it zeros. Okay, by combining the first with the second and then the first with the third. Okay, now what do we do? Okay, so now we're going to move on. Now that we've done the second step, we're going to move on to the third step here. It says now that we've done the first two steps, we made sure this was a non-zero number on the top left, and we made sure that these became zeros underneath it. The third step says now find the first non-zero number in the second row. So now we're going to move our focus away from that top left-hand corner number and working with that to now going down to the second row and finding the first non-zero number, which is this right here. Okay, that's the first non-zero number as you move from left to right. That's the first non-zero number in that row. Okay, we call that the leading number. The leading number in each row is the first non-zero number in each row. You'll hear me say that word or those words, leading number, a lot here. So 1 is the leading number in the first row. -10 is the leading number in the second row. Okay. Now, so excuse me, if it is to the right of the leading number in the third row, interchange the two rows now. That is not the case. But if, for example, let's say that this had been a 0 right here, and this -5 was right here, then you'd want to interchange the rows, okay? But that's because, as it says here, you need, if the second row is further to the right, the leading number, if it's further to the right than the leading number in the third row, okay, that we can't have that. It can't be that way. And you'll see why here when we talk about echelon form, okay? But that's not the case here. The leading number in each row currently right now, it's not going to stay this way, but currently it's they're both right on top of each other. So you don't have the one in the second row to the right of the one in the third row. That's when you'd have to interchange it. Since they're the same, they're not to the left or right of each other, they're just on top of each other, you can leave it that way. You don't need to do anything. So now we can, excuse me, go on into the step 4 there. And it says take that leading number, -10, and we're going to use the second row, very similar to what we did with the 1 up here. Very similar thing, okay? We take the -10 and we use it to make the numbers underneath it equal to 0. Just like we do with the 1, making the numbers underneath it equal to 0. Now we take the -10 and make the -5 into 0 by using the -10. How do we do that? Well, as you can imagine, since we need to use the -10 to change the -5, we need to combine the second and the third row together. Okay, how can I do this here? In a similar way that we've been doing it here, if I multiply the third row by -2, wouldn't that make this the opposite of this up here? Okay, because it would make this 10, wouldn't it? Okay. So let's do that here. Let's go -2 times the third row. We're going to add that to the second row because then at that point you'll have +10 and -10. But then we want that result to be in the third row because we want the third row to have the 0 right there. Okay, so combining those together, they'll cancel. It'll give me a 0. All right, it'll be equal to 0 when I add them together. Same thing as canceling as we talked about. But then we want that 0 to go here. So that's why the result will go in the third row. Since it goes in the third row, the first two rows are going to stay the same. Only the row that you change, only the row that is going to be where the result comes, all right? Like we said, anytime you add two rows together, the result has to go in one of those two rows that you added, all right? But we want that result to go in the third row because that's where we want the 0 to be. So let's try that here. So we got what here? We got 0 times -2. Again, I'm going to distribute the -2 to each number here, just like I did on the previous steps. 0 times -2 is 0. -2 times -5 is 10. -2 times -14 is 28. Okay. And -2 times -78 is 156. Okay, now we then need to add those two rows together with the red numbers being added to the second row. Okay. Just like we did before, add the two rows together. The row that you multiplied, use the red numbers and add it to the other row. 0 plus 0 is going to be 0. All right. 10 plus -10 is 0. All right. And by the way, I want to just back up for just a moment here real quick. Notice that we got 0 plus 0. That kept the 0 right there. If that 0 hadn't stayed as 0, I would have ruined what I did earlier. Okay, once you get these zeros right here, you guys, they got to stay as zeros. As you'll see, that's going to be important here for echelon form. These need to stay the way they are as zeros. If you don't do these steps in the exact order that I'm showing you here, you're going to end up probably changing these numbers at some point, and then you'll be just going around in circles, and you won't be able to get to echelon form like we need. Okay, so it's really important that you do these steps in the order, meaning these steps right here that we've been looking at. Okay, let's keep going here. 28 plus -26 is 2. And finally, 156 plus -152 is 4. Okay? Okay, so step 4 is now done here because we needed to get the numbers underneath that that -10 number, which was the which was the leading number in the second row. That's -10. Okay, we needed to get the numbers underneath that equal to 0. We did that. Okay, it says continue this process. Last step, continue this process for all leading numbers in each row. Okay, so now we go to the third row, right? The leading number in that row is 2, isn't it? All right, in other words, it's the first non-zero number. Okay, and then it says, what does it mean by continue this process? It means to, after you identify the leading number in the next row, you then make the numbers underneath it equal to 0. But there are no numbers underneath that. So let's find out what that means now. It says, continue this process for all leading numbers in each row. So we got the 2. And then it says, remembering that during this entire process, if you get a row with all zeros, immediately interchange rows in order to get the all zero row at the bottom. I'll talk about that when we get to a problem like that that's going to have. You're sometimes going to see some rows that have all zeros. Don't worry about that right now. But it just mentions that there in case you run into that, okay? But as long as you've now done this thing for all rows, and the third row is the last row, all right? You identified your leading number. You don't have to do the step where you make zeros underneath the 2 because there aren't any. And so we're now done with doing that process. It says now the matrix should be in echelon form. Okay. And so, and as a reminder here, on each step, you're only allowed to use the matrix row transformations. Those are the 3 things I've been pointing out to you. Okay, you're only allowed to do these things on each row, or on each step, excuse me. And so we've been doing that. Okay, sometimes we've only done the third one, in fact, but you could actually the second one is pretty much the same thing as the third one. It's just saying that you could multiply just one row and then not add it to another. But I guess, you know, actually it's not really exactly the same. But there's no purpose in doing the second one normally unless you do unless that's part of doing the third one. So really, the first and the third are going to be the only ones that we're really going to do. Okay, but yeah, you could theoretically do the second one also. That's why it's mentioned here. Okay, and the interchanging the rows, we'll see that coming up here as well. I mentioned briefly a few minutes ago that sometimes that's necessary, but don't worry about that yet. I'll mention it carefully when we get to a time when it's necessary to do that. Okay, so, but usually we're going to use that third one more than anything. Please remember that on that third thing, okay, you can only multiply a row by a non-zero constant number. So when it has this third thing here where you're allowed to multiply by the rows and then add them together, you can only multiply by numbers that are not zero. And it has to be a constant. You can't multiply by a variable. Okay? That would completely ruin things. And that's what we've been doing, right? We've only been multiplying by non-zero constant numbers like -2 or -3 or -6, those kinds of things. Okay? So anyway, it is now in echelon form according to my directions, but you're probably wondering at this point, well, how do we know that though? Here's how you know that it's in echelon form. It's now time to talk about that. What does it mean for a matrix to be in echelon form? Let's take a look at it side by side here. It says a matrix is in echelon form if it has the following properties. The first non-zero number in each row, in other words, the leading number in each row, is to the right of the first non-zero number, in other words, the leading number in the row immediately above it. Okay, let's test it out. Okay, you'll see here that there's 3 leading numbers. I'll put them in red here just so you can see them a little bit better. These are currently the leading numbers in each row, the first non-zero number in each row. Isn't it true that each number is to the right of the leading number, each leading number, each red thing I circled here, is to the right of each leading number above it? It's not always going to be in this diagonal format here. Usually it will be. But as long as each leading number is to the right of the leading number that's right above it, okay, then it's in echelon form, as long as the second thing is also been verified, and that is if you do have one of those rows that is all zeros, which we don't this time, but if you did, then it's at the bottom. And we'll talk about how to make sure that that happens if you have a problem that does have one of those types of rows. Okay, so don't worry about that. But we can see that that first thing is satisfied here, and then the second thing in this problem is not even doesn't even need to be worried about. You don't have that type of row. So this thing is in echelon form. Okay, finally, we got it in echelon form. Okay, and we're going to see plenty more examples if you're still trying to get used to what this whole echelon form thing means and what the steps are. Don't worry. But now that I have it in echelon form, okay, what you do is you consider one of these 3 possibilities. You have to do it in this order, though. But this will tell you what type of answer you have so that you'll then know how to find that answer. Okay, what are these 3 things? Again, you got to do this in order, so you got to look at number 1 first and ask that question. It says if the matrix contains a row with all zeros except for the last one to the right of the vertical line, the right of the bar, okay, then the system has no solution. Is that the case here? Do we have a row that's all zeros except for the last number? No, we almost do. If this had been a 0 right here, then there'd be no solution because then you'd have all zeros except for the last one. But that's not the case. So number 1 is not true. If it's and it says if there's no row like this, then consider the next possibility. Okay? So if number 1's not true, then move on to number 2. If it was true, then you stop right there and you'd say, hey, there's no solution, and then the problem is complete. But since that's not the case, I'm going to read step 2 now. It says, if each of the variables in the system serves as a leading variable. Okay, stop right there. A leading variable, you guys, that means that that variable has a leading number. Let me show you what I mean. We know from our original problem that the first column is the, and you don't have to write this down, but the first column is the x column. That's where the x's were. The second column is the y column, and the third column is the z column, right? Okay, I circled all the leading numbers, right? If a variable has a leading number after you get it into echelon form and you've circled all of your leading numbers so you can see them and everything, if each variable has a leading number, okay, that means that each variable is a leading variable. Okay, it has a leading number here. You'll see some problems later where that will not be the case, where, for example, you'll see a problem where x and y will have a red circle with one of its numbers. It'll have a leading number, but z won't, okay? Don't worry, we'll get to that. But since each variable has one of these leading numbers that we circled in red, that means that number 2 does work, okay? So let's keep reading here since it works. It says if each one of them is a leading variable, then the system has one solution. We saw that back in the last section. Sometimes systems have one solution. All right. So it says we can find the solution using back substitution, which we'll learn right now. Let me show you that. Okay. So at this point, once you identify that you've got just one answer, what I want you to do is I want you to rewrite the system with the variables back in there again. Okay, so in other words, this would be 1x plus 3y, and it's plus because this is positive. 1x plus 3y plus 5z. Remember, the bar means equal, so equal to 26. The next one, though, notice that we start to see some zeros here. What do the zeros mean? It means you don't have to write, when you put it back into equation form, you don't need to write that. It'd be like saying 0x minus 10y. Well, 0 times x is 0, and so it'd be just like you were adding 0. Okay, so don't write the zeros when you put the variables back into the problem, okay? Just say this, negative 10y minus 26z is equal to negative 152. And so in the last one, we have a couple of zeros, so all we need to do is say what? We just need to say 2z is equal to 4. Okay? And so now, here's how you do the back substitution. You first of all take the equation that has only one variable in it and you solve it. Well, you can see there that since, just like all these equations here, these are linear equations, and so since it's a one variable linear equation, we just divide out right there on that step, don't we? Okay. So we got z equal to 2. Okay. That's just one variable. How many variables do we have in this problem? We have 3, right? Different from the previous section. In the previous section, we only had 2 variables. But because we had 2 variables, what did I have to do, you guys? I had to solve for both of them, didn't I? Since I now have 3 variables, I need to solve for all 3 of them. All right, and then instead of having an ordered pair, like I did here, x and y, I'm now going to have what they call an ordered triple. All right, it's going to have 3 parts to it. And so instead of having two numbers together, you're going to have 3. I'll write that all out here, but I'm just telling you where we're going with this. So once you solve for one variable by picking the equation that has just one variable in it, you then take that, kind of similar to what we did in the last section here on this step. You take that and you go back and plug it in. Don't plug it into this one. And you got to plug it into the equation that has that variable you solve for along with one other variable. Because if you plug it into that, guess what's going to happen? You're going to end up getting an equation that has just one variable in it. That's what we want on this last part of the problem. We want just equations that have one variable in it after we substitute into it. Okay? So we started out with the one that had one variable, we solved it. We then plug into the one that had 2 variables in it, okay, assuming that this variable you solved for was one of them, because then when you plug it back in, it will then all have only one variable left. And then we solve that one variable equation. Okay, and then we'll be able to solve the last one after that. Okay, Remember, when you plug a number into an equation, particularly if it's a polynomial, which these always will be on these systems, all right? Figure out what the term is equal to that you plugged into. That's negative 52, isn't it? Okay. And so since it's negative 52, we're going to say minus. If it had been positive 52, we'd say plus. Okay. And so that gives you that right there. And then we solve for y. How do we do that? We add the 52 over to the other side. Negative 152 plus 52 is going to be equal to negative 100. And so then after I divide out, I get y equal to 10. Okay, we're almost there, you guys. I've now solved for z and I've solved for y. So now that I have solved for both of those things, if I now plug both of them into this one, I can then solve for the one variable that I haven't solved for yet, which is x. Let's do that right now. So that's what it means to do back substitution. You start out with the equation that has one variable in it, you solve it. And then you go to the one that has two variables in it, assuming that one of those two variables is the one you solve for. You then plug it into that and solve that. Then you should now have two answers, meaning the answers for two of your variables, and then you go back and plug it into the one that has three variables. Okay? And we get what here? Let's see. Again, figure out what each term is equal to that you plugged into. I plugged into 3y and 5z. And so I get x. And since that's positive 30, I'm going to say plus 30. This is positive 10, so I'm going to say plus 10. And then I solve that equation. So combine like terms. And then if I move the 40 over to the other side, I get x is equal to 26 minus 40, which is negative 14. Okay? And so, finally, we solve for all three variables. As the directions promised us, there should be just one answer. That means that there should be just, one answer. So, that means that there should be just one x, one y, and one z, and that's exactly what we got. So what's the final answer here? What you do is you write it like this, you guys. You write it as the x, just like what we did with x and y. It's just that we have the z in there also. Okay, so you write it x comma y comma z when you have three variables. X comma y comma z. You don't have to write down the x, y, and z. I'm just illustrating it here for you. X, y, z. Okay, and that's how you write it out if you have one solution. Okay, if you have an infinite number of solutions, we'll talk about that. Okay, if you have no solution, you just say those two words, no solution. But if you have one solution, this is what you do. Okay, so as you can imagine here, you guys, this problem took us a while, but that was just because we'd done it for the first time. It'll get easier and faster the more you do it, like with any math problem, don't worry. But because they're still kind of long, even if you do go faster, okay, what I'm going to do right now is I'm going to show you the answers and the work, of course, to a lot of other problems here so that we can go faster while still hitting all of the major concepts that you need to know. Because like I said, these problems go in a lot of different directions depending on what kind of problem you get. And so I want to show you a lot of examples. Okay, a whole lot of examples. Yeah, this is the first one I wanted to do. I just wanted to make sure there. I want to show you a lot of examples to make sure that not only do we get a lot of practice, but make sure that you've seen all the different possible things that you might run into. Because like I said, these problems do go in a lot of different directions. All right, not all problems are anywhere near the same. Okay. So in this next one here, again, I did the same thing I did in the problem that we just did. All right, I set it up where since the x's, the y's, the z's, the equal signs, and the constant terms are all lined up, you just bring them right straight down into the matrix like this. Okay, and then what did we say we had to do first, you guys? What did we say? We said that you have to make the top left-hand corner a non-zero number if it's not already. It is already, and it usually will be. Okay, so, but just double check that. All right, if there had been a 0 right here, you could have, for example, you could have just flip-flopped these two rows. You could have just took the second row, put it up here, and the first row, put it down here. But that wasn't the case, okay? So you didn't have to do that. Okay, what you do, as we did in the last problem, after you establish that this is a non-zero number, you then make the numbers underneath it equal to zeros. Okay, how do we do that? What you do again is you combine the first and the second row in order to make this number 0. In other words, you add them together so that the x's cancel, and then you put the result in the second row so that there would be a 0 there since the x is canceled out. Okay, then you do the same thing with the first and the third row where you make the x's cancel out and then you'll have a 0 there. Okay, how did I do that here? Let's take a look. I needed to multiply this row by -2 right here, and that's why it says -2 times row 1 right here. -2 times row 1 will then make this -2. If I then add it to this 2 right here, it'll become a 0. Let's go ahead and write that out. Okay, so if I multiply the first row by -2, this is going to be -2. This one's going to be -6. This one will be 12. And then, let me zoom in a little bit for you there. And then this last one will be -14. So again, we add the temporary numbers to the other row here. All right, because we don't want to do row 1 plus row 2, you guys. We want to do -2 times row 1 plus row 2. That's why we had, see, -2 times row 1, that's the red numbers. That's why we got to add the red numbers to row 2, okay, in order to get it to cancel. And so what do we get? We get 0, -7, 13, and -13. I just added the red numbers to the second row on each one of those. And there you go. So then we do that same thing with, we need to make this number a 0 also. How do we do that again? We got to combine the first and the third row together. Again, don't combine the second and the third. Okay? We do first and second to make this one a 0, and then we do first and third to make the third one 0. That's how it works. Okay, again, please do not divert from that. Like I said, that could lead to problems, okay, getting the right answer, even if it looks like you're on the right direction. Okay, so what did I do here? I multiplied the first row by -1, because if I do that, I'll get -1 plus 1, and then it'll cancel out. Okay. So I need to multiply the first row by -1. That's going to make this -1, -3, +6, and -7. So all those numbers in the first row become those red numbers that I just wrote down right there. If I then add those to the third row, like it says to do here, and then put those results in the third row, okay, because that's where I want that 0 to be, then I get what you see right here, 0, -1, 8, -8. -1 plus 1 is 0. -3 plus 2 is -1. 6 plus 2 is 8. -7 plus -1 is -8. Just making sure that we were remembering how that process worked. What did we do after we got the zeros underneath this number up here at the top left? We then moved over to the first non-zero number in the next row, right? And we then, once we established what that was, we then make sure that the numbers underneath that become zeros. So I need to turn this one into a 0. All right, since I need to use the -7, just like I used the 1, since I need to use the -7 because it's the leading number, you always use the leading number to make the other number zeros. Okay, always use the leading number. This is the leading number in this row, isn't it? Okay, I use that number to make these zeros. So now you take this leading number and you make the numbers underneath it equal to 0, okay, by using that number. Okay, so how do we do that? Well, we realize that if I multiply -1 by -7, all right, it will then cancel with that -7. So you have to combine the second and the third row. You have to use this row with the leading number to make this number 0. That's why we combine these two rows. And we don't do row 1 on this step. All right. So if I do that, what does the third row become here? -7 times the third row. It's going to become 0, 7, -7 times -1. -7 times 8 is -56. And then negative 7 times negative 8 is positive 56. If I then add these 4 red numbers to the numbers in the second row, I get 0 plus 0 is 0. See how I didn't ruin, like I said in the last problem, see how I didn't ruin the fact that these need to still be zeros. Okay. Negative 7 plus 7, all right, is going to be 0. So again, we put our results on the final row here. Negative 7 plus 7, put it there. Negative 56 plus 13 is now negative 43. Again, it goes in the last row because that's where we want it to be. That's where we wanted that 0 to be. So everything's got to go there. And then 56 plus negative 13 is positive 43. It goes down there. Okay. So now we've done what? We've taken the top left-hand corner. Okay, make sure it's a non-zero number, and that will make it the leading number in that row automatically if it's non-zero. Then you make the numbers underneath it 0. Then you go to the first non-zero number in the second row, and then you make the numbers underneath that equal to 0. Then you go to the next row and you do the same thing. The first non-zero number there, the leading number there, and then you make zeros underneath that. Oh, but hey, wait a second. There are no zeros underneath that, so we're done. That means it's in echelon form. Okay, and we can confirm that by realizing that each leading number is what? Each leading number is to the right of the leading number that's above it. This is to the right of that. This is to the right of that. Okay, negative 43 is to the right of negative 7. Negative 7 is to the right of 1. Okay, it's in echelon form. All right, now, once we get it in echelon form, what do? We say, hey, if a matrix contains a row with all zeros except for the last entry, is that the case here, though? No, we don't have a row like that, do we? Okay, so we go on to step 2 here. It says if each of the variables in the system serves as a leading variable, in other words, does each variable, okay, again, the first column is the x column, the second column is the y column, the third column is the z column. Does each column have a leading number? Okay, that would make it a leading variable. Each column does have a leading number. X has 1, Y has negative 7, Z has negative 43. Since each variable has a leading number, it is going to be, once again, just like in the last problem, it's going to be one solution. All right. Yes, we will see a situation where number 2 doesn't work and we have to go down to number 3. It's going to be a bit more complicated, but we'll be okay. We'll get through it. So, since it's going to have one solution, then we'd back substitute, okay, just like we did in the last problem. You start out with, and let me write this out. You don't have to write out the equations as long as you write them out eventually over here by doing one at a time. But I like to write them out, just like I did in the last problem, so that we can just see everything in front of us here. But you can see that I just wrote out each equation when I needed it here. But you might find it easier just to write it out like this so that you can see what you have, okay? So let me do that. And so putting the variables back in the same way I did in the last problem, here's what the system would now look like. As I said in the last problem, you start out with the equation that has only one variable in it. You can see I did that right here. I divided both sides by negative 43. That's how I got z equal to negative 1. I then did what? I then took that answer and I plugged it into the equation that has 2 variables in it. You can see I did that here. Okay. And then I solved that. I got y equal to 0. And then now that I have 2 answers for 2 variables, z and y, I now plug both of those answers into the equation that has 3 variables, okay, and then I can solve for that third variable. And we end up with these 3 answers. Okay, so that's what happens again when you end up with just one solution. Okay, so let's move on now to the next problem here. And also has one solution. I'll let you read this on your own time. We've talked about a couple of problems like that already where it has one solution. But I'll put this in your packet for one major reason here. It's because notice how it obviously looks like a smaller system than normal, doesn't it? But it actually is the same size. It's just that, in other words, it still has 3 variables and it still has 3 equations, just like the other systems we looked at in this section. It's just that some of the variables are missing and it makes it look like it's smaller than it is. So I just want to warn you here that when that happens, make sure to put zeros in the spots where there's no variable. So in the first equation, there's no z, so put a 0 in the z column. The second equation, there's no y, so put a 0 in the y column. And then the third one, same thing with the x right there. So just wanted to give you a heads up on that. Okay. Other than that, it's pretty much going to follow the same process that the other equations have. In fact, you don't even need to do the step here. See how I changed the 2 into a 0 right there? You don't need to change this one into a 0 because it already is a 0. So it allows you to skip a step there because it was already done. So that's nice. All right. Okay, so we're going to stop the video right here. When we come back for the second part of this section in the second video, part 2, we will start to see problems that have no solution, which is also known as an inconsistent system. At least your textbook will refer to it as that. And also we'll see when you have an infinite number of solutions. So we'll see those scenarios as well. All we've seen so far is just when we have one solution, as we talked about. So join me back here again for part 2 of the video coming up in the next video.